Advanced Functions, Lesson 1. Our goal in this lesson is introducing polynomial functions in general form and talking about their end behavior. P at x equals an xn plus an minus 1 x to the power of n minus 1 plus a2x2 plus a1x plus a0 is called a polynomial degree n when an is not 0. ai's are real numbers and they are called the coefficients, and x is the independent variable in the polynomial function. It has n plus 1 terms if all coefficients are not 0. Each of these is called one term. So a polynomial degree n, an(xn), the first term, is called the dominant term, and an is the leading coefficient if we write it in descending order. a0, which is a0x to the power of 0, is called the constant in the equation of the polynomial. Px equals a0 is constant. The graph is a horizontal line. Px equals a1x plus a0. It's called a linear function. The graph is a line with the slope of a1. If a1 is positive, it's when we move from left to right, it's moving upward, and if a1 is negative, it's downward. Px equals a2x2 plus a1x plus a0 is called the quadratic trinomial. It has three terms: trinomial, monomial, binomial, trinomial. The graph is parabola. It's upward when a2 is positive and downward when a2 is negative. When the degree of polynomial is 3, it's called cubic polynomial. It has four terms: a3x3 plus a2x2 plus a1x plus a0. a0, a1, a2 could be 0, but a3 shouldn't. The graph is in one of these forms. Generally speaking, if n is even, we call it even degree polynomial, and if n is odd, we call it odd degree polynomials. Examples of odd degree monomial: px equals x, px equals x3, px equals x5, and even degree monomials: x2, x6, and x8, x2, x4, and x6, as long as the exponent is even. We know the graph of px equals x, px equals x2, and px equals x3. They can be easily drawn using a simple table of values. For example, for px equals x4, when x is 0, y is 0. When x is negative 1, y is 1. When x is 1, y is 1. When x is negative 2, y is 16. When x is 2, y is 16. If we plot the points and join them, the graph is similar to the graph of x2, closer to the y-axis. The graph starts from the second quadrant and extends to the first quadrant. This is called the end behavior of the function. Therefore, the graph of x3 starts from the third quadrant and extends to the first quadrant. We say from q3 to q1. And here we say from q2 to q4. The end behavior of a polynomial function is exactly the same as the end behavior of the monomial containing the dominant term. If n is odd and an is positive, it is always from Q3 to Q1, and when n is even and an positive, it's always from Q2 to Q1. When an is negative, we have reflection in the x-axis. Let's have a couple of examples. Y equals 2x3 minus x2 minus x minus 1 is an odd degree polynomial. The degree is 3. The dominant term is 2x3. The end behavior is from Q3 to Q1. It's odd and the coefficient is positive. Y equals negative 3x4 plus 2 is another example. The dominant term is minus 3x4. It is an even degree polynomial. The end behavior is from Q3 to Q1. When it is even and coefficient is negative, it's always from Q3 to Q4. Let's recap. In this lesson, we introduced the general form of polynomial function, and we categorize them in two categories: when n is even and when n is odd, and we'll talk about their end behavior. Thank you.